Science has progressed so far from where it started. We can now travel in space to the celestial bodies that are millions of kilometers away from our Earth. Now we can see what is there in the cold space. However, as Sir Isaac Newton said, what we know is a drop, what we don't know is an ocean. There are still mysteries in the vast space that humans have not discovered yet. Hello, and welcome back to our channel. Today the topic of the video is what we know about black holes and what we don't. What is black hole? How does it get into existence? How much do we know about it? And what is there to discover about this mysterious existence in our universe? These are questions that still need to be answered by scientists today. So let's jump into the space. What we know about black holes. Humanity was not familiar with black holes until 1783. The first idea of a black hole was announced by an English country parson, John Michell, in 1783. In 1916, German physicist Karl Schwarzschild used Einstein's theory of general relativity to deduce that any mass could become a black hole if it were to be tightly compressed. In 1971, this idea became reality and the world discovered the first black hole in history. Let me tell you what we know about black holes so far. What is black hole? A black hole is a region in a space with gravity so strong that even light or other electromagnetic waves cannot escape it. The first black hole, Cygnus X1, was discovered in 1971 by several different researchers. Dr. Hawking is famous for his research on black holes. He found that black holes emit radiations that can be detected by X-ray detecting scopes such as the Chandra X-ray Observatory. How is a black hole formed? The vast majority of atoms present in stars are hydrogen atoms, which are massive assemblies that formed when an immense gas cloud collapsed under its own enormous gravitational force. At the core of a star, nuclear fusion transforms hydrogen atoms into helium atoms, releasing a tremendous quantity of energy that is so powerful it can sustain a star for millions of years. The energy produced in a star's core, through nuclear fusion, produces radiation pushing outward and opposing the inward force of gravity. This delicate balance creates a stable star as long as the fusion can sustain itself. Yet for stars with several times the Sun's mass, the intense heat and immense pressure at their core enable them to fuse heavier elements until they reach iron. This remarkable fusion reaction that produces iron does not produce energy, unlike all the previous elements it has produced before. This is because iron is the most stable element in nature, thus making it an ideal endpoint for nuclear fusion processes within stars. When the amount of iron in the star's core reaches a critical tipping point, the delicate equilibrium between gravity and radiation, keeping the star stable, is abruptly disturbed. The core breaks down in less than a second, and the star collapses. The process is truly awe-inspiring as it harnesses immense amounts of energy instantly, releasing it into space and causing shockwaves that ripple throughout the universe. The star's core, traveling at approximately 1/4 the speed of light, becomes increasingly dense as it continues to travel. This incredible process creates the heavier components found in our universe, such as gold and iron, a phenomenon that occurs during a supernova explosion. As a result of the extreme gravitational forces at play, the star either forms a super-dense neutron star or, if the core is large enough, collapses entirely into a black hole that swallows all light and matter around it. Types of black holes. Scientists have categorized different types of black holes based on their masses. These are stellar, supermassive, intermediate, miniature, only stellar, and supermassive are common and have been researched by scientists. When extraordinarily massive stars die and collapse in on themselves, stellar black holes are created. These are dispersed throughout the universe and are thought to weigh between 10 and 20 times as much as our Sun. Scientists estimate that millions of these powerful and mysterious stellar black holes could be in our Milky Way galaxy. Since they absorb everything that enters their intense gravitational field, including light, these objects are, by their very nature, extremely challenging to detect directly. As their names suggest, supermassive black holes are very giant in size. These are tremendously big, with some millions to billions of times more massive than our Sun. Though they can be located at the center of almost every galaxy in the cosmos, including our own Milky Way, scientists can still not precisely explain how these enormous and mysterious objects form. Sagittarius A, the supermassive black hole at the heart of our Milky Way galaxy, is predicted to have a mass of 4 million suns and a diameter about equal to the distance between Earth and our Sun. Fascinating, isn't it? There is so much coming for you in the next part, so don't miss out on the best part and join me to the end. Event horizon. What you see as a black hole is actually an event horizon. Event horizon is the outer boundary of the black holes, a point of no return. To pass through the event horizon, you need to move faster than the speed of light, which is impossible. Light gets absorbed when it passes through the event horizon. Thus, no reflection occurs. So we just see the black sphere, singularity. If the black hole we see is the event horizon, what is in the center? The center of the black hole is known as the singularity. The singularity is an infinitely small and dense point, meaning that all of its mass is concentrated into a single point in space that has neither a surface nor a volume. It is a place where the laws of physics, time, and space are all broken. Accretion disks. Black holes can only be found and studied by studying their effects on nearby objects because they are undetectable. In this context, it's important to notice accretion disks, which are made up of gas and dust atoms and circle around as they get closer to a black hole. While quasars are the ejection of particles from supermassive black holes, what we don't know about black holes. Till now, we know about the structure, types, and background of black holes, but there is more that is hidden inside the black holes. What is inside the black hole? This is still a mystery to scientists, and we don't know what is inside a black hole. Do we just die? Is this a gate of the multiverse? According to what we currently know about physics, matter cannot be entirely destroyed. But when it goes into a black hole, it seems to disappear. There is no way to know for sure, but some people think that matter gets transformed into a new kind of energy. What happens at the singularity? The idea of a singularity, described as a point of infinite density at the heart of a black hole, remains a profound mystery and has not yet been fully understood despite our current level of knowledge. This is due to the fact that current physical theories are unable to properly describe and explain what occurs after this point, forcing the creation of a new quantum theory of gravity. Interaction of black holes. Furthermore, we still don't understand how black holes interact with one another. A massive amount of energy is known to be released in the form of gravitational waves when two black holes merge into a single, bigger entity. However, we still need to gain the knowledge and equipment to understand how this process occurs or how common it is in the universe. The future of black hole research. Despite their mysteries, scientists are still investigating black holes to understand more about the universe. Gravitational waves, which are disturbance in space-time's fabric brought on by the motion of enormous objects like black holes, are one topic of study. A prediction predicted by Einstein's general theory of relativity was confirmed in 2015 when scientists discovered the first gravitational waves from two converging black holes. Exploring supermassive black holes at the galaxy center is another study area. Scientists are attempting to comprehend these black holes' formation, growth, and interactions with their respective galaxies. We must understand supermassive black holes to thoroughly learn the history of galaxies, which is regarded as one of the most important aspects of the universe. We appreciate you taking the time to watch this video to its end. We hope this video has piqued your interest and motivated you to discover more about the universe's mysteries. Please share your opinions in the comments. Don't forget to click the subscribe button to see more fantastic videos like this.